Okay, y'all ready? Number 2, it gave you the balanced chemical equation already, okay? It gave it to you, and it's like this. Yes, I will. Okay, and it tells you, it asks you what mass of aluminum will react with 150 grams of iron 3 oxide, okay? So we're starting with the mass of iron 3 oxide, and we're going to find out how much aluminum it would take to react with that, okay? So this is my known, and this is my unknown, okay? Make sure you keep track of what you have and what you are looking for. The first thing you write down in the math problem is your known. Now, how can I change that to moles? Yes. I'm going to say iron 2 times, here's my periodic table. It's 55.85. And oxygen's 3 times 16. This is 111.7, and this is 48. It's 159.7 grams of iron oxide, and this is 1 mole.
Hey, give me just a second, because
I am.
Yeah, after everything, you gotta take a second.
Okay.
What is that 100?
159.
That one.
This one?
No.
111.
Mass.
Pardon me, honey?
That right there.
This 111.7, and this is 48.
And that equals 159.
Yes. Okay, so this is how much is per 1 mole. That's why we put this up here like this. This is always going to be 1 mole of your known. Do you get me on this? The top right here is always 1 mole of your known, and this is always the molar mass of your known. We are looking for mass of aluminum. What was the definition I gave you of a mole to begin with? It's merely a what?
Conversion.
Conversion factor, okay? Now we're going to use that balanced chemical equation. We're looking for how many grams of aluminum there are, so we're going to use the mole ratio from the balanced chemical equation. This is 2 moles of aluminum for every 1 mole of iron 3 oxide used. This is called the mole ratio, and you must use the balanced chemical equation at this point.
Okay, say that again. How come? I understand where you said times 2 aluminum. Why'd you put that 1 FE?
Because there's only 1 here. If there's no number,
But why did you put the FE 2 up there on the bottom?
because I need it to cancel out right here. Okay?
So it's 2 mole aluminum.
Yeah, I'm sorry.
That's wrong.
Okay, thank you. Okay, now, this right here is always going to be 1 mole of whatever you're looking for. Okay? This is 1 mole of what you know. This is 1 mole of what you're looking for. And when you look for aluminum, it's 26.98 grams of aluminum per mole.
So don't worry about the 2.
No, the 2's done here, baby. You've used the 2 already. This is only the molar mass.
What did we use the 2 to get, though?
The 2 is this is the mole ratio, which is going to enable you to swap from one type of substance to another type of substance. Okay? That's what the mole ratio is for. So let me show you. Look, the grams of iron oxide will cancel, not the numbers, but the units and the substance. Moles of it will cancel. Moles of aluminum cancel, and all you're left with is grams of aluminum, which is what you're looking for.
There's still 1 mole of aluminum on the top, though. From that, there's 2 aluminum. Right?
Sweetheart, just wait. Hold on just a second. I don't think you're understanding what I'm talking about. So this is how much we were given. This is the molecular mass of iron 3 oxide. This is the mole ratio. For every one of these I use 2 of these. And then this is the molar mass of aluminum.
Okay, but when you're doing the molar mass, you don't.
I don't multiply it times 2
Why not?
because I've already used that 2 right here.
Okay, but if you wouldn't have,
Yes.
then you would have been more.
So when I do this, I say 150.
Where did you get 266.98?
It's the.
It's not 266, it's just 26.98. It's the
Up from there.
What are you asking, baby?
So you took 2 aluminum times
whatever. No, that
That's
is.
just one aluminum.
This is the mass of 1 aluminum.
What's that?
See here, wait a minute, not too many questions at one time. Do you see here, Brianna? Okay. We have already used the 2 from the balanced chemical equation here in the mole ratio. So we don't use it again. Okay? So I say 150.
Hang on, sorry, I don't mean to keep.
That's all right.
But because whenever we did the FE2, we did include the 2.
I use this 2, but there's no 2 in the formula here. This is just the moles.
So you add in the subscripts, but you.
Yeah. That's how much, you have to have 2 irons here and 3 oxygens to get the molar mass.
So if it would have, the 2 would have been the subscript.
Yes,
then you would have-
yes,
okay, well,
yes.
that's-
Okay, thank you. Now, I'm going to say, just say, I'm going to say 150 divided by 159.7 times 2 times 26.98. And you're going to get 50.7 grams of aluminum. Now, listen to me, okay? You just ignore any ones, because if you multiply or divide by a 1, you get the same thing, right? So all you have to do is say this divided by that times 2 times the molar mass of aluminum, and that's your answer. Yes.
How can I just completely single off that 2? Because I don't know why it messes me up. Like, okay, I see what it is. You're getting rid of mole of aluminum, not 2 mole of aluminum, whatever. Anyway, so okay, I get it now. I just don't know how to explain it.
Okay. Well, understand that to have aluminum oxide here, you've got those subscripts, right? And you'd have to multiply aluminum times 2 and oxygen times 3. But because we're using the coefficients, the only place you can use coefficients is the center part right here. Okay? That's your mole ratio, and that's the only place you can use it. Okay? Does that help any?
So, is that a 2x
Where, baby?
on the mole ratio?
Oh, 2 over is 1.
It's 1 mole. It's 2 moles of aluminum over 1 mole of iron oxide.
So whenever you're doing that, you're only focusing on the one side of the equation that it's talking. Like, is it? Like,
Well, for this one now,
Oh.
I'm gonna add a little bit to the next one. Okay. So in this one, it asks you. The question was, if I start with 150 grams of iron 3 oxide, how much aluminum should I use? Right?
How much will react?
Yeah.
2.7.
Uh-huh. So that's why you did all this. You have to convert this to moles, because the only way you can change from one substance to another is with the mole ratio. That's the only way you can change it. Then once you do that, you convert it back into grams, and you've got how much aluminum would be used. Now,
Is it always going to be like that?
I'm going to show you a different one. Okay?
So then on 2B, you do the same thing.